All right, so we are talking about quadratic functions here. Quadratic function. In a quadratic function, you'll recognize, first of all, f of x is just function notation, right? It's the same thing as the letter y. We've talked about that a lot. So f of x is equal to ax squared plus bx plus c. We've talked about this format before, right? We talked about this in factoring in the last chapter. So it's nothing new in terms of what we're going to see, in terms of the equation, the function, but now we are graphing, okay, which we haven't done before. We're not factoring, we're graphing. Okay, so that is your quadratic function. This is the standard form for that quadratic function. A, B, and C, of course, are numbers. For this to be a quadratic function, A cannot be 0. A cannot be 0. Because if A was 0, then we'd get rid of that x squared term, right? Because 0 times anything is 0. So if A was 0, this term would be gone. That's a linear function. It's not quadratic anymore. It's quadratic because of the square. Okay, because we have an x squared, that's what makes it quadratic. So A can be positive, can be negative, can be a decimal, can be a fraction, can be anything we want except for the number 0. Okay. All right, when we go to graph a quadratic, our graph is going to look like this. Okay, and this graph is called a parabola. Parabola. Not parabola, but parabola. Sometimes you'll hear me say it's a U shape, but the technical term is parabola. And we've got some stuff that we need to know about a parabola, some different parts of it that we need to recognize. And you see them up there. So that picture that's in the middle, I want you to have that down in your notes. Okay, so the drawing of the parabola with the different wording around it. I want that whole picture down in your notes. I'll give you a couple minutes. Copy down that picture, and then we'll talk all about it. All right, so as you're finishing that up, I'll talk about it. So you see that parabola, that U shape. A couple things to point out about it. The very bottom, or it's going to be the very top, is going to be called the vertex. Okay, it's that very bottom point, or if our parabola went the other way, then it would be the very top point, right? So that vertex is that very highest or lowest point on that. The axis of symmetry, okay, we know symmetry is the two sides look exactly the same, right? If they are symmetric, the two sides look the same. So our axis of symmetry is this line that cuts the parabola exactly in half. It goes down through the center. It goes through the vertex all the way through. And since it's a line of, or an axis of symmetry, that means the two sides are symmetrical. Whatever you have on one side, you have on the other. Okay, it looks the exact same on both sides. That is the axis of symmetry through the middle. You'll see they talk about this decreasing versus increasing. For the decreasing and increasing, and they're going to ask you this in the homework. They're going to ask, where in your parabola is it decreasing and where is it increasing? All right, so what we need to do is we need to think about reading it from left to right. Okay, reading it from left to right. If we go from left to right, we are coming down, so we are decreasing, and then we are going up, so it's increasing. So we would say in this situation that it is decreasing when x is less than 0, right? Because that's the negative side. It's decreasing when x is less than 0. And it would be increasing when x is greater than 0. So you are going to see questions tonight on that. They're going to give you a graph. They're going to give you a parabola. They're going to ask, what's the vertex? What's the axis of symmetry? Where is it increasing? Where is it decreasing? Right? They're going to ask all of those things about that one parabola that they showed. Right? Now, if the parabola was facing the other way, it was opening down like this. Again, we're reading it left to right. So it's increasing first, right? Even though the arrow is shown pointing down, okay, and that can be confusing sometimes. Read it left to right. Left to right, this is going up, so that's increasing and then decreasing. Okay, always read it like a book. Read it left to right. Ignore the arrows when you do that. It's just where is the line? Is it going up or down? Okay. All right. Any questions about our kind of vocab here on the parabola? Okay. You see right here the parent function. We talked about parent functions. We talked about translations. We're going to our transformations. We're going to talk about transformations again today. The parent function is right here. That's the parent function. That's the most basic version of this quadratic function. Is f of x is equal to x squared. That's the most basic version. And that's what the graph they've shown you right here is. This is f of x is equal to x squared. All the other functions are just transformations of this. And so we'll talk about transformations. And really, we're only looking at 2 transformations today. We're going to look at a stretch and shrink, and we're going to look at a reflection. Okay, and that's all we're doing today. All right. Let's take a look. All right. We're just going to point out here some things, and this is, we've already talked about what they're going to ask you to find. This is just kind of pointing those out so we can visualize it when it's not just a generic graph, when it's actually on the graph. Okay, remember I said they were going to ask you to find the vertex. Vertex is that bottom point or that top point. That's at the point -1, -2. They're going to ask for that axis of symmetry. The axis of symmetry, guys, is a line. It's a vertical line. Okay, vertical line that comes through. And any vertical line has the equation x is equal to a number. So your axis of symmetry, and we abbreviate axis of symmetry A of S. So you can abbreviate it A of S if you want, or you'll just see me doing it. Our A of S is always x equals a number because it's an equation. It's an equation of a vertical line. So this is x equals -1. That's a vertical line at -1 is my A of S. We've got it still decreasing on the left side here, increasing on the right. They're also going to ask you, along with all these other things that they're asking you, they're going to ask you for domain and range. Tell the person next to you, what do you think the domain and range are for this graph?
greater than -2 less than
All right, here we go. Virginia, what is the domain? Those of you that can see the whole screen, this is easy for you. Levi, what's the domain? All real numbers. That's right here. All real numbers. For those of you in the front that can actually see. Yeah, domain is all real numbers because we got those arrows, right? Domain is your side to side, and we got arrows, so it's going on forever. So domain is all real numbers. Okay. What are our range? Ranges are up and down, remember, right? Perfect. Y is greater than or equal to -2. Because the lowest value you could have is that -2, right? And we can have anything taller than that, anything up from there. So y is greater than or equal to -2 for that. Okay, so it opens up, it's going to be y is greater than or equal to something. If it opens down, it's going to be y is less than or equal to something. It all depends on where that vertex is and whether it's going up or down. All right. I'm not going to have you name all of those things for these. What I want you to tell the person next to you, I want you to tell them the vertex and the A of S. Okay, vertex and A of S. Go.
And that one's 0, so that's like 2.
All right, what's our vertex for this first one? What's the vertex, James?
2, -3.
2, -3. Okay, there's our vertex. Vertex is a point. Okay, what's our axis of symmetry? Going to be here. Okay. Yeah, and it's going to be x is equal to 2. Okay, got to have that x equals. Okay, that's one of those things that I'm going to be very particular on the quiz and the test. If I ask for an axis of symmetry, it has to be x equals. Otherwise, it's half off. Okay, it's got to be x equals because it is an equation of a line. It's not just a point. Okay, it's an equation, so it has to be x equals. All right, over here, what is our vertex going to be? Ethan? -3, 7. Thank you. And what is our A of S, right? X equals -3. There you go. Now, I want you to notice something, and maybe you already have. That A of S, that x equals number, that's just the x value from our vertex. Okay, that is always going to be the case. Because that A of S goes through the vertex. Right? It cuts it exactly in half through the vertex. So these numbers will always be the same. The x value of your vertex and the x equals for our A of S. All right, good. Questions on that? Okay. Good. So now we got to talk about actually graphing. Okay, actually graphing it out. So let's say that we have f of x is equal to 3x squared. F of x is equal to 3x squared. So what we're going to do for today is we're just going to plug in our numbers. So we're going to plug in those 5 numbers that we seemingly always plug in. -2, -1, 0, 1, and 2. Don't forget about order of operations here. If I plug in a -2, Am I gonna multiply the 3 times the -2 first, or am I gonna do -2 squared first?
-2 squared.
Gotta do the exponent first, right? And then multiply. Make sure if you're gonna use a calculator, you're putting that in parentheses if it's a negative. Okay, anytime you plug in a number, it's gotta go in parentheses. How would you go ahead and find your y values, please? Find your y values. You either do it in your head, write it down, use calculator, whatever you need to do to get this. Be careful of your negative, if your order of operations is correct. Once you get those 5 y values, I want you to check with somebody, see if they got the same 5 y values.
3, 0, 3.
All right, here we go. Raise your hand, tell me what are my y values here? Type. There are my y values, right? If I'm plugging in a -2, it's a -2 squared, got to be in parentheses if you're going to use that calculator, because that's a -2 times a -2, which is a +4. And then 4 times 3 gives us 12. The same thing with a -1. -1 squared is 1, times 3 is 3. Today, because we are only dealing with, and I don't know if I told you this, it's on the I can statement, but we are only dealing with equations that look like this today. We are not dealing with the plus bx plus c. We're only dealing with ax squared. Okay, this is kind of our intro. We're going to step it up every day. We're only dealing with the ax squared. So today, you're always going to have 0.00. And 0, 0 is always going to be your vertex when you go to graph today. Okay, so anytime we have just that ax squared, 0, 0 is going to be our vertex. Okay, we're not moving it up and down, side to side at all. So it's just a matter of getting those other numbers, and it should follow a pattern. Okay, the top 2 numbers should be the same as the bottom 2 numbers, because we're creating this U shape. And remember, we have an axis of symmetry. It's symmetrical. So whatever you have on one side, you got to have on the other. So if we go to sketch out that graph, 3, 6, 9, 12, we're going to have 0, 0, -1, 3, -2, 12, right? It should give that nice U shape to it. Okay, it's not a V shape. It's not an absolute value. If it was a V shape, it would be out here, right? It's not a V, it's a U. So it curves up. Okay. On the homework on big ideas, it's going to be one of those choose the correct graphs. Okay, so you should get this on your page, right? Everybody, yes?
Yeah.
This should be on the page, and then it's just choose the right one. Okay. All right. Good. So that's the idea behind graph. Okay. Now, let's talk. We got to talk transformations, because that's what they're going to ask you about. Transformations. Tell the person next to you, what transformation do we think that is represented?
What transformation? Well, we go Oh, yeah.
Okay, here we go. Any ideas on what transformation? I know it's been a while since we talked transformations. What transformation do you think is happening here? Ethan? Yeah, exactly. This is a vertical stretch by a factor of 3. Because we're taking all of our values, all of our original y values, we're multiplying by 3. They're getting 3 times taller. Right? We're multiplying by 3, so 3 times taller. This is a vertical stretch by a factor of 3. So whenever you're multiplying by it, that's the factor. If it's bigger than 1, we're getting taller, so it's a vertical stretch. If it's smaller than 1, if it's a fraction, if it's a decimal, we're getting smaller. That's a vertical shrink by that factor. Okay, so if we ended up with f of x is equal to 1/2 x squared, this would be a vertical shrink by a factor of 1/2. We're not dealing at all with horizontal stretch or shrink. Okay, it's just straight vertical stretch or shrink. The only other thing that we're going to see today is a reflection, and a reflection over the x-axis. Raise your hand, what do you think that would look like? What would I change about this equation to make it a vertical or a reflection over the x-axis? What would I change? Eli?
Negative.
It'd make it a negative, yeah. All I would have to do is make that a -3. And then negative, that's going to be a reflection over the x-axis. Because then that's going to make all my y values negative now. So instead of 12, 3, 0, 3, 12, I'm going to have -12, -3, 0, -3, -12, right? It's going to be down here now. So the only transformations that we're dealing with here today, vertical stretch or shrink, and that's the number, that's the coefficient, vertical stretch or shrink. And then if it's a negative out in front, it's a reflection over the x-axis. Okay, it's not bad at all. On the graph, you're just plugging in those 5 numbers, you're getting your points, you're choosing the right graph. Any questions? Apparently not.